Welcome back to part 2 of the platinum recovery from the jeweler's scrap. I'm going to start this off by taking these solids that we filtered out. We're going to add this to a beaker. Come on out. There we go. And now what I'm going to do is add some hydrochloric acid to this. Fill it up to about the 200 milliliter level. I'm going to cover this up, put it up on the heat. Alright, I forgot to turn the camera on. I had about 30 milliliters of nitric acid in here, and I added it to our mixture in the back. So now we're starting to get some foaming going on. Of course, I should have known from the previous experience that we were going to get that. Alright, we'll just keep an eye on that back there. Should have used a bigger beaker. Rinse this funnel out. And we're going to do a stannous chloride test on this solution that we got in part 1. See what we got going on in here. I don't expect too much now, remember. And there's a stain that kind of gives us an idea of what the concentration of platinum is going to be. Now we're going to add this solution that we filtered off in part 1 to this beaker. Let's put some pieces of zinc in here and cement the metals out one more time now that we've got the solution concentrated. And we're going to try to cement out the platinum group metals, and there'll be copper in there, of course, onto the zinc. Those last 2 pieces of zinc were turning a red color. And what that indicates to me is that we were cementing out copper. And so what I'm going to do now is stick a piece of filter paper down here. See what we got going on in this solution. Do a stannous test. Just barely, hardly anything in there. I think we've got all the metal cemented out of there now. While I'm waiting for this solution to get done reacting, what I'm going to do is come back here, stick a piece of filter paper down in here, and let's see what we got going on in our beaker that we have Aqua Regia on the filtered solids. Let's see what happens here. Oh man, look at that. So we definitely got a bunch more platinum group metals in those solids. Way more than we had in this beaker, actually. So we got a lot more platinum in here than I suspected. What I'm going to do now is pour off this liquid into a waste beaker. See what kind of metal we got down on the bottom of this beaker. Alright, we definitely got some metals that formed down in the bottom of this beaker. Let's see if we can get a look down here. Should be some valuable metal in those solids. There's a cable that connects from my phone to the transceiver. If I hit that cable, it kills the sound. Here you can see I'm rinsing those solids with a little bit of distilled water. We'll add the rinse to the waste container. Decent amount of solids there. We'll set this off to the side. Here, if you look down at the Stannis test, that's a respectable amount of platinum we have in that solution in the back that we've been boiling in aqua regia. So we're going to take this down off the heat now and allow it to cool. Here I'll rinse down the solids off the inside of the beaker with some hydrochloric acid. I want to avoid using water here because sometimes a funky precipitate will form if we use water in these platinum solutions. Next, what I'm going to do is put the hot beaker in a container, add a little bit of water, and then we're going to fill it up with some ice cubes to artificially cool it off for us so we can continue to work with that solution. Got to pull it through a filter. A hot solution might make the filter fail. Here you can see the temperature is 35 Celsius and 96 Fahrenheit. So now we've got our specially folded filter inside that Buchner funnel. That's to capture all of the solids. None of it will get past that filter paper when we have it folded that way. So we're going to go ahead and pour our liquid through this filter. See, I'm dampening the filter with some hydrochloric acid. Here we go. We're going to pour this through that filter now, capture the solids in the filter, and filter out the valuable liquid so we can recover the platinum out of that liquid. Most of that liquid is pulled through there now. I'm going to rinse the filter with a little bit of hydrochloric acid. We've got all the solids filtered it off. And now what we'll do, get this out of here and out of the way. I'm going to transfer this solution into a clean beaker. Oh, that looks gorgeous as far as platinum group metals in solution. Look, it's important to point out that the second extraction that we did right here is much richer in platinum. I think it's because when I did the initial extraction, I only added about 9 or 10 milliliters of nitric acid to it, and that was not enough to get all the metal out of those solids. So the second time around I added 30 milliliters and give it a good long boil. So that's why we got a higher concentration in this second extraction. Here we go. We're gonna start adding some pieces of zinc, and cement the metals out of this solution. This one should be a little cleaner and not have as much copper in it. Here we go. Hey, that's going to chew up that zinc very quickly. Lots of acid in there. That's okay, we got plenty of zinc. What we're trying to do is get the platinum group metals out of here and concentrate them for further refining. I had a fairly large amount, relatively, of nitric acid in here, and so what we're going to get is a vicious cycle where the metals precipitate out, and then that excess nitric in there will cause it to redissolve, and then it'll precipitate back out, redissolve, precipitate back out, and that'll continue until we get all of the available free nitric acid consumed out of here by adding these pieces of zinc. Here you can see the that black powder accumulating down around the pieces of raw zinc that's still in there. That's going to be our platinum group metals, mixed PGM black powder. I think the reaction is complete. Here is the Stannis test from the Aqua Regia boil before we precipitated with our zinc. Now what I'll do is I'm going to dip this filter paper in here now. It's going to have a little bit of black solids on it, but we're going to get another Stannis test here. Make sure we've got all the platinum group metals precipitated out. And that test confirms that we do. That blackness down there is just some solids that are suspended in this solution still. All the metal's been precipitated out on the zinc. Here's a look down in the beaker. I've allowed this to settle overnight. So now what we're going to try to do is get rid of some of that foam that's on the top there. We're going to try to extract it with this vacuum hose. Get rid of some of that foam. Let's see what we got. It's not a whole lot, but I do see some black material under that liquid. There's some zinc in there. So now what we'll do is I'm gonna put some water in here, of course. And we gotta burn the rest of that zinc off of there. So I'm going to add a little bit of hydrochloric acid to consume the rest of that zinc. All the zinc is gone now. We just got that one little piece there that's still kind of dissolving. Now let's tilt the beaker a little bit. You can see the black powders that have formed on the bottom there, those black solids. That's our platinum. It's not that much, but this stuff is a nightmare to work with. What I'll do is just tilt the beaker here and see if we can get it to settle out a little bit. Stuff suspends in that solution. Doesn't want to settle well. This is typical for platinum group metals. I disturbed the mic cable and broke the sound. So here I've allowed it to settle for about 30 minutes. What we're going to do is use our vacuum bottle and pull the waste solution off of those black solids in the beaker. Vacuum off the waste solution is more efficient, because if we tried to pour that liquid off, a lot of the black powder would go over with the pour. I had the solids from the other beaker sitting in some water, so we'll pour that off into our waste container. Now we'll add the solids to the other beaker, so we got everything in one beaker, using hydrochloric acid to rinse the solids out of that beaker. Cover it up, put it up on some heat. I'm going to start adding small amounts of nitric acid. See if we can dissolve this one more time. Just a little bit at a time. Got some ammonium chloride. I'm going to dissolve some of this in some water and make us a concentrated solution of ammonium chloride. We'll drop some of the solution. Transfer it to this beaker. Lots of platinum. All right, so now what we'll do is take our little sample here, and I'm going to add some of this saturated ammonium chloride solution to it. Let's see what happens here. Well, we get a precipitation going on. That should be platinum coming out of solution with that ammonium chloride. Just set it down here and let it settle for a second. That seemed to have worked fairly well. I've added some more water to our ammonium chloride. And so now what we're going to do is we'll set this off to the side. There's our platinum salt, ammonium hexachloroplatinate. We'll set that back out of the way. And now what we'll do is transfer this solution that contains our platinum into the beaker. Before I pour the ammonium chloride into our platinum solution, let me dip a piece of filter paper in here and see what we got left in our solution. Still got a decent amount there. That's an orange color, so that means we still got a lot of platinum in that solution. I'm going to add a little bit more ammonium chloride to this, and we're going to douse it with some distilled water. Give it a stir. It would be tempting to add more ammonium chloride to get the rest of the platinum to drop, but that's not how it works. What we have here is about 100 milliliters of platinum bearing solution in our beaker. I've got about 70 milliliters of ammonium chloride. Here we go. We're going to add it in and precipitate out the platinum. Platinum is nothing like gold or silver. With gold, if we still had gold in solution, we just add some more SMB until it all dropped out. Platinum is not like that. We're going to have to put this solution into our stock pot. Let's put this remaining ammonium chloride down into this little container. Now we're going to gather our platinum salt into a filter. I'm using the ammonium chloride water to wet the filter. Now we'll collect our ammonium hexachloroplatinate in the filter. I use ammonium chloride water to rinse the salt out of our beaker. Can't use water. Plain water will tend to redissolve the platinum salt. Here's our platinum salt down in our funnel. Over here, if you look, I poured off the solution. And there's some crystals forming down in the bottom. It's probably ammonium chloride crystals. In this beaker that we started with, I've got some precipitate in here too. Not sure what that is. But I'm not going to add it to our platinum. Probably just add this to the stock pot. So now what we'll do is we'll just start rinsing this. Try to get all the green rinsed out of it with this ammonium chloride water. Here is our ammonium hexachloroplatinate salt. And what we could do right now is put that into a fused quartz dish, burn it, and make some platinum sponge. If you notice, there's still quite a bit of green in it, so it'd be heavily contaminated with copper. And so what I'm going to do now is just, we're going to put it in this, add this to the container down here, a tightly fitted container. And just hang on to it. Alright, this probably about a gram of platinum. And the proper thing to do here would be to take this, redissolve it, and reprecipitate it a second time to get all that green stuff out of there. What we're going to do is call it now. That's about maybe a gram, gram and a half of platinum. So this will conclude the Jeweler's Carpet Platinum Recovery video. I'd like to thank everyone for watching.